So hi, my name is Guarav. I'm an intern over here at the Sun core Solaris team, and I'm actually a PhD student at UC San Diego in computer science. So the stuff that I've been working on is a feature called instruction-based sampling on the AMD 10H processors. So it's a performance observability tool which lets you analyze how the instructions are actually performing on the processor at real time. So many modern processors actually provide this observability functionality through performance counters, which let you aggregate data over related to performance like the number of cache misses, TLB misses, and whatnot. But the problem is that although they give you aggregate at the end, it doesn't let you allow to identify what is the root cause for the performance or lack of performance. So that's where AMD's instruction-based sampling comes in and bridges this gap. So what it allows you to do is that in an instruction stream, it allows you to pick one of those instructions and analyze it in the sense that whether it causes a cache miss. If it causes a cache miss, it provides you a wealth of information related to it, like its address, how much was the cache miss latency. IBS basically works at two levels. At the fetch level, when the instruction is being fetched, if you want to sample that part of it, then it tells you whether the instruction actually missed on the iCache, whether it was aborted, did it go through, and whether there was a TLB miss or not. And the second part is that during the actual execution of the instruction, during that phase, it tells you whether there was a data cache miss, whether there was a load, whether there was a store, in case there was a cache miss, how long was the latency. So this is the kind of information which is otherwise not possible to get at all. So ultimately what we're looking at is a combination of maybe performance counters and IBS, where performance counter tells you that if there are any bottlenecks in performance due to some kind of cache misses or something, and IBS actually lets you identify the culprit or the actual address which is causing the maximum number of cache misses, because it even tells you that with the virtual and the physical address of the instruction causing the cache miss. All this information you can never imagine to get through any other mechanism. So the thing is that we have all of this information at the hardware level available to us. There should be a way to convey this information to the application developers, which can allow them to profile what is the performance bottleneck in their application. So that's where the Sun's a great tool called Dtrace comes into the picture. So what we have done is that we've developed a Dtrace provider for instruction-based sampling feature. So the way it works is that it provides simple Dtrace probes to the application developer, through which he can basically get all this information at regular intervals. So the way it works is that you specify whether the kind of information you're looking for, maybe at instruction execution or maybe instruction fetch. And what it does is that it provides you all this information which instruction-based sampling hardware is collecting at regular intervals to you as part of the Dtrace probe and its predicates. So the predicates allow you to filter the performance data you are actually interested in, maybe corresponding to the application that you're running, and then basically manage and visualize it using the powerful aggregation tools available through Dtrace. So basically the current status is that a fairly full-featured prototype of the IBS Dtrace provider is available on the Open Solaris website, and you can get it from the AMD IBS gate over there. So give it a shot. I'm sure it's going to help you.